All right, welcome back, everyone. I'm glad to be here again for the second series in my Python workshop. I'm glad to see that everyone's attended today. I'm really happy to see a lot of new faces here. But since I'm a little bit time constrained today, I do want to just jump straight into it. And so today I want to go over some mathematical operations and more about types. And I want to explain more about variables. And I believe in the next lecture, I'm either going to be covering, it really just depends on what I feel like. It's either going to be strings or we're going to jump right into functions and conditionals. They're both, I think, pretty difficult topics to cover as they require a lot of testing by you on the other end. But for now, I just want to talk about this, and I'll probably talk about input as well today. All right. So let's just get started, I guess. So let's talk. I want to talk more about some mathematical operations and types. But before that, I want to correct a typo I made in my previous lecture. So earlier, I claimed that we couldn't do multiple commands in the same, or like multiple additions or subtraction in the same command line. But I was actually incorrect. You can just do something like this. And so by adding in a semicolon, it'll separate the output basically. It separates the two commands out. And so we still want to do it in the file though, because it's a lot easier for us to control and fix things. But just in case you want to do quick operations here, you can do multiple by just doing something like that. All right. And so let me just make that for next lecture. All right, let's talk about some mathematical operations. So before we talk about int and floats, and I want to just show some funny things that can happen. So let's say I want to do an addition between 4.0 and 4. What does everyone think is going to happen here, right? Well, I run it, and you see that we end up with a floating point value. And so you might be wondering, like, oh, why am I not getting an integer value instead? Why am I getting a floating point value? And that's because of something called type conversion, or in this case, it's implicit. So one of the things you'll end up learning is that each of these types takes up space in the computer's memory, or the program's memory in this case. And so we're converting it up to 4.0 because 4.0 is a bigger size than the integer type. And so because of that, we have to move up to the bigger size to compensate for float. So you'll see if we do anything like maybe like 4.0 minus 4. I print 4.0 divided by 4. Or how about 4.0 times 4? I run all of these. I'm going to get floats for all of them. But let's say that we want an integer value to be returned instead. We don't want this decimal point. Well, we can do something as simple as this command. 4.0 times 4. And I run this. And you're going to see here I get 16 when I do 4.0 times 4 in this line here. So let me explain what's going on. What's going on here, so we first do 4.0 times 4. And based on the rule that we established earlier, this is going to be a floating point value of print int. I'm going to just put this in brackets, float 16.0. All right. And so you can see here that we have a float value. So by putting int and putting the product in here, we're typecasting. I'll write that down. We're typecasting. So what that basically means is that we're casting this value of float to a new type of type int. So we're casting a float to int. And so by doing that, we can change the type and it'll end up dropping to 0.0 because, right, integer values do not have decimal points. And we can even see this in the other way around too. Let's say I want to do something like, I want to convert 4 times 4 into a float value again. I can do this right here. And wow, you can see I'm getting 6.0 here. So using something like this, we can switch it, we can hop back and forth between different types as long as we cast it within our, or at least we cast the value with the, in the parentheses. And moving forward, some of the things I want to talk about for types as well is that you need to know that floats can be very weird sometimes. So I'm going to demonstrate. Let's say I want to add in this weird float value here, 4.1.3 and 4.001. I'm going to try and add these right here. And you can see I'm getting the right value here, right? That's not too bad. But floating point values can have a very weird output as well. So I'm going to do this value. And I know this is going to have something weird. Yeah, right here. So you can see for some reason, I'm getting like 10 extra zeros and a 1 at the end. So what is going on here, right? Well, it has to do with binary. essentially. So floating point numbers can have inaccuracies due to binary addition. And all you know for binary now is that binary is a 0 and 1s that are how programs run or how computers just like operate in general. And so what you should know is that be careful with floats because you can get wonky output like this. So like, for example, like how would we fix this? Let's say that we want to make sure we only get these 3 decimal points here. We want to make sure we have this. Well, we can use a function that's predefined within Python. And there's multiple ways of going about this. I'm only showing one way of doing it. But one function we can use is the round function. So I do print round 4.121 plus 4.13. Now I'm going to run this. Let's try this out now. Oh, sorry, I forgot one parameter value. Let me run this now. And you can see I'm getting, oh, sorry, I'm messing this up. It's like this. Like that. So 8.2.51. And we're getting, let me explain what round does. So first, round, if we just look at this, if you look at round and if we just start parentheses, we can see what the parameters will be. So we'll take a number, which is going to be the sum of 4.121 and 4.13, and it's going to take the number of digits we want to return. So earlier when I mistakenly didn't put anything in here, you can see I got nothing returned here because I didn't want any digits to be returned. So if we don't leave anything, it'll always turn it basically to an integer value in name, but it's still a float technically. But just so you know, you can use the round function here to make sure you convert it to a certain number of decimal points you want. All right. Let me just make sure there's any questions that want to be asked. Let me see. Let me stop sharing quickly. Okay, doesn't look like there's any more questions. I'll keep going. All right. So now that we've talked about types, let's talk about variables. So best way to think about variables is just think about like mathematics. We can assign anything to a variable, and we can arbitrarily create any variable we want. Although there are certain conventions we do want to follow to make things look cleaner. But for demonstration, I'm just going to assign this value x equal 1. And let's print out x. Oh, and also let me, just to show for better clarity, let me comment out this part of the code. See, I'm printing out x. And you can see for my value of x, I have 1. So what's going on here? Well, basically, when we declare x equals 1, Python automatically assigns variable types, which is somewhat handy. So by saying x equals 1, because we know that 1 is not a float value and we know it's an integer value, Python is smart enough to tell us that, oh, this value x will be a type of int. And we can even see this when we do print type of x, and I run this. And you see this is a class of int, and we didn't even have to declare that. In something like C plus or C or C++, the common convention would be something like int x equals 1. You would actually have to declare the type of the variable before we create it. But because of Python and how it works, and because it's automatically assigning it, we don't need to bother worrying about that. So right, we can do something like x equals, let's do like y equals 1.0, z equals hello. Let me just print y, let's print z. I think this should work. Yeah, you can see here, I'm printing out multiple things on this line, but I'm also printing out 1.0 and hello. And if I were to go into like do the type of each one, it would tell me it's a type of float and a type of string. Okay. So it's important to know what type you're using, because I think if you don't know, like if you plan on taking like C or C plus or one of the other ones, you will actually have to declare the types. So just keep this in the back of your mind whenever you're using these variables. And one of the nice things about variables is that by having a variable, we can always just change the value whenever we feel like it. So we can see earlier, if I did something like maybe like 1.1, right? I will get 2. But let's say we want to change the second variable, random variables. It's very irritating if we just have to keep manually doing like 1.1.11, 1.1.13, anything like that. But instead, by doing this, let's just go to my example of x equals 1. Let me delete this statement, or I'll just comment this one out for now. Or no, let me delete it. Sorry. Yeah. So let's say I just want to now change it to x equals maybe like 10. And And let's now print out x. So you can see now the value of x has changed because we assigned a new variable to it. In fact, we can do a lot of random things with this. Let's say I even want to change this like 1.0, what I was doing earlier. You're gonna see now we have 1.0. So Python is very smart about this, and it's very easy to switch between types and variables thanks to this. It's a lot more troublesome in C and C++ because again, we will have to cast every time we want to change it, or we'd have to use specific functions. So that's one of the nice things about Python because it does it all for you in the background. I can even change this to a string here if I felt like it. Yeah, and I would just get hello there. So, sorry, my voice is dry again. It's nice to know all these things here. If I were doing the C++, it would probably look something like, string of whatever value I had here, whatever. But, or even like maybe I'll just have to cast it again, just so you know in advance. So casting is really important to know about because you will see a lot in C++ and whatever. But let's just keep moving forward with what we're doing. But now that we know what the variables can be and what we can assign, and just so you know, just for context, you can make anything a variable. I can say this as a variable as like 10, and I can print this, and you'll see that I'm gonna get 10. But one of the nice things about variables is that you want to have a variable that's relevant to what's at hand, or you want to just keep it as succinct as possible. You don't want to just have random names because it makes reading the code very difficult and hard. So I'm just using x for the moment because we don't exactly have a function defined yet. So I'm just using a very simple variable, which I'm comfortable using. But it really is up to you what you want to use. Just make sure you make it kind of short and to the point, and it should be relevant. Okay. And now let's talk about getting input from the console here. So let's say that I want the user to put in a value for me. I want them to assign me a variable of x, not within the file here. I want to make it so that I can keep getting a new value of x without changing this here, and I'm going to print out that value. All right. Let me just write out the goal we want to get. The value for x and print it out. All right, cool. So let me explain how we would do this. Let me first write the bottom part of the code. I'm going to write print x. And above here, we're going to have one line of code. We would, let me explain it. So first, I'll just write out the code and I'll explain it. We'll do input. And that's it. It's as simple as this. So let's talk about what's going on here. So when I type in this function input, I don't think it doesn't say exactly what it does right there. I'll run the code first, and let me just show. And so right here, you can see that I'm not getting these arrow markers, which indicate that the program has finished running. What's going on here is that when I type in input, it's waiting for the user to input something to the console, whether it be a string, or actually in this case, input will always be a string. So let's say I put in the number 100, for example. It prints out 100 for me as well. And let's make sure, let's print out the type of x as well, because this is something we need to make sure we know about. So I'm going to run the program again. Let me print out 100. All right. And you can see that I'm printing out 100 and the class is string. So an important distinction to know is that input will always be a string. Okay, just the function by default. And we know that earlier we can do something like 100 in a string, which is why I'm also getting 100 here. All right, just so everyone knows about that. So we run into this trouble of what if we only want integer inputs? Like we don't want a string, we want to return an integer type. Well, right, it's as simple as well as going over before. All we would have to do is do something like this, int input. We would just need to make this into an integer value by casting it. And so again, you can see here, I'm going to type in 100. And now it's giving me a type of int instead because I casted it here. All right. And so one thing that's important to know is that we want to still be careful here because even though we're testing to make sure we return integer value, the user can still input anything they want here. So if I were to run this again, and let's say I want to input a string because I just feel like it. I put hello. you're gonna see I'm gonna get an error because X here is gonna convert to an integer value. And because we're putting in a string instead, it can't convert it. And so because of that, we're running into errors. And so there are ways to go about this that I'll cover later when we talk about more about functions. But just keep this in mind for now that if the user really stress tests and tries to break your program, it's very easy to break a statement as simple as this. We would have to have some tests or we would have to have kind of like catch-alls to make sure that the code will not take in invalid parameters. So like I'm forgetting the exact term for how it's used, but we want to make sure that it would pass all the test cases. All right. And so another thing we can do with input, just so we know, if we're just assuming we're going to take in integer values, is that we can also type in the string here. So let's say I want to type in the string, enter input here. When I do this, let me expand this screen too. And so this isn't going to change any of the functionality of the program. All that's going to happen is that now I can see a string here. And because I left the space as well, it's going to put me off a little bit to the side. And then I can type in my value here. I put in 10. Oh, sorry, wrong one. Let me run the program one more time. I put in 10, and it's going to return me everything I want to hear. Okay. So just within input, just know that you can also put in a string. So I can write anything. I say like, put your number here. And I can run it down. And I can put like 100. And I'm going to get all the values returned properly. All right. So your string here can just be any kind of message you want to output for your certain function. But again, it's really up to you. And with that, I think I'm done for this second workshop because I don't want to go too far into the next phase yet, because they will take a lot longer to argue about, or not argue, a lot longer to talk about because they're a lot more complex. All right. Any questions? All right, cool then. It was great talking again, and I hope to see everyone at my next workshop.